Find the inverse Laplace transform of inverse Laplace transform of xs is equal to s square plus 2s square plus 6 divided by s square plus 3s. So this is given equation. Here degree of numerator is greater than the degree of, this is s cube, sorry. Here degree of numerator is greater than the degree of denominator. So we perform the long division here. Okay. We write here degree of numerator is greater than degree of denominator, so we perform long division. So it is s cube plus 2s square plus 6 divided it is by s square plus 3s. So it is s cube plus 3s square. So signs. So it is minus s square plus 6. Again it is multiplied by minus 1. So it is s square minus 3s, sign change. So it is 3s plus 6. Therefore x of s is equal to s minus 1 plus 3s plus 6 divided by s square plus 3s. Now consider x1 of s is equal to s minus 1 and x2 of s is equal to 3s plus 6 divided by s square plus 3s. Now first we calculate the inverse Laplace transform of this x1 of s. So we have delta t, its Laplace transform is 1. Now according to differentiation property, we write here according to differentiation property, d by dt of x of t, its Laplace transform is s into xs. Therefore d by dt of delta of t, its Laplace is s into 1. So Laplace inverse of s is d by dt of delta t, delta dash of t. Therefore x1 of t is equal to delta dash t minus delta of t. Now we have to consider x2 of s. x2s is equal to what? It is 3s plus 6 divided by s square plus 3s. So we can write 3s plus 6 divided by s into s plus 3. We can write this as a1 by s plus a2 by s plus 3. Now here we have to calculate the values of a1 and a2, these two coefficients. So here A1 is equal to A1 is equal to S into 3s plus 6 divided by S into S plus 3. S is equal to 0. So it is 6 by 3 is 2. And A2 is equal to S plus 3 into 3s plus 6 divided by S into S plus 3 at S is equal to minus 3. So it is minus 9 plus 6 divided by minus 3, it is 1. So x2 of S is equal to 2 by S plus 1 by S plus 3. So we can write this equation x2 of t is equal to 2ut plus e raised to minus 3t u of t, and x1 of t is equal to x of t is equal to x1 of t plus x2 of t, so which is equal to delta dash of t minus delta of t plus 2ut plus e raised to minus 3t u of t. So this problem was asked for 6 marks in exam. Next problem. Find inverse Laplace transform of x of s is equal to s square plus s minus 3 divided by s square plus 3s plus 2. Now here the degree of denominator and numerator is same. So the function is not in the proper form. So to obtain the function in proper form, we perform the long division as follows. So we write here degree of numerator and denominator is same, so function is not in proper form. To obtain the function in proper form, we perform long division. So here is it is s square plus s minus 3 divided by s square plus 3s plus 2. So it is 1 s square plus 3s plus 2. So sign change, it is minus 2s minus 5. Therefore here x of s is equal to 1 minus 2s plus 5 divided by s square plus 3s plus 2. Now consider x1 of s is 2s plus 5 divided by s square plus 3s plus 2, and x2 of s is equal to 1. Therefore x of s is equal to x2s minus x1 of s. This is equation number 1. next one, sorry, not next one. Now we obtain Laplace inverse of x1 of s using partial fraction expansion. So x1 of s is equal to what? It is 2s plus 5u divided by s square plus 3s plus 2. So we can write it 2s plus 5u divided by s plus 1 s plus 2. Now here we use partial fraction. So x1 of s is equal to a1 by s plus 1 plus a2 by s plus 2. Now we have to find the values of a1 and a2 here. So a1 is equal to 2s plus 5u divided by s plus 1 s plus 2 into s plus 1. So its value is, we substitute this value here and we get minus 2 plus 5 by, it is 3. Now we have to calculate a2 also. So it is 2s plus 5 s plus 1 s plus 2 into s plus 2 at s is equal to minus 2. So we, after substituting, we get values, it is minus 1. Now we replace the values of a1 and a2 in above equation. So we get x1 of s is equal to 3 by s plus 1 minus 1 by s plus 2. Now we have standard Laplace transform equation. Standard Laplace transform equation is, what is e raised to minus 8t u of t? Its Laplace transform is 1 by s plus a. So we can write above equation in the form of this. Therefore x1 of s becomes x1 of t. It is 3 into e raised to minus t minus e into e raised to minus 2t u of t. Now we consider x2s. Now consider x2 of s. So x2s is equal to 1 and we have delta t Laplace transform is 1. So we can write x2 of t is equal to delta of t. Now we have the values of x1 of t and x2 of t. So we put these values in equation number 1 in the form of t. So x of t is equal to delta t minus 3 raised to minus t u of t, minus minus becomes plus e raised to minus 2t u of t. Now this is case, this was the case 1. Now second case is when there are complex root. So we write here case 2 when there are complex root. When there are complex roots. So if there are complex root, then equation of x of s can be expressed as xs is equal to a1 by s minus alpha minus j beta plus a2 by s minus alpha plus s minus alpha plus j beta plus so on. Now here the poles p1 and p2 are the denominator alpha plus j beta and alpha minus j beta. We write here poles are at P1 alpha plus j beta and P2 alpha minus j beta, that is poles are complex conjugate of each other, that is but procedure of obtaining time domain signal is same as that of the case 1. But how to obtain the time domain signal? It is same as that of the case 1. Now next problem. Find inverse Laplace transform of x of s is equal to s square divided by s minus 1 s minus half square. So this is for casual time domain signal. For casual time domain signal. Now here we write down the step 1. So we write down here given equation. Given equation is xs is equal to s square divided by s minus 1 s minus half square. So there is a single pole at plus 1. We write here there is single pole at plus 1 while there are repeated poles at plus half. Okay, now next is step 2. Now step 2 is for the repeated pole in partial fraction expansion form, equation of xs can be written as, we have to use here partial fraction expansion form. So we write here for repeated poles use partial fraction expansion form. So we can write this equation as x of s is equal to a1 by s minus 1 plus a2 by s minus half plus a3 by s minus half square. Now we have to find the values of a2, a1 and a3 here. Now here we have to note that one thing, that is the second term in the equation of x of s is an added term. So the coefficient of a1 and a3 are calculated using earlier method, that is a partial fraction, but the extra coefficient is a2. Okay, so this coefficient is calculated taking the derivative. What we have to remember here the second term is added term. a1 and a3 can be calculated by using same form as that of the previous problem, but the a2 has to be calculated by using or by taking the derivative. So first we calculate a2 and then we calculate a1 and a3. So first is a2 is d by ds of s minus half square into x of s at s is equal to half. So a2 is d by ds of s minus half square. Write down this equation. At s is equal to half. So a2 is d by ds of s square by s minus 1 at s is equal to half. Therefore a2 is s square into d by ds of s minus 1 plus s minus 1 d by ds of s square at s is equal to half. Therefore a2 is s square minus 1 into we have to solve it. Now we substitute the value of s here. So a2 is, we have to substitute here value of s, and by solving we get it is minus 3. So here a2 is minus 3. As this second term is added term, so we have to take the derivative of a2. We have to take the derivative to solve or to find the value of a2, and in this way we can find the value of a2. The value of a1 and a3 can be calculated as it is, that is as the same method, previous method. So now we calculate a1. Now a1 is s minus 1 x is at s is equal to 1. Therefore a1 is s minus 1 into s square by s minus 1 s minus half square at s is equal to 1. Therefore a1 is s square by s minus half square at s is equal to 1. So we substitute 1 here and we get a1 is equal to 4. Then a3 is s minus half square into x of s at s is equal to half. So it is s minus half square into s square, s minus 1 s minus half square at s is equal to half. So by substituting this value we get a3 is equal to minus half. Now we substitute, we put values of a1, a2 and a3 in the previous equation. So equation becomes x of s is equal to 4 by s minus 1 minus 3 by s minus half minus half divided by s minus half square. So these are the values of a1, a2 and a3. Now next is step 3. Next is step 3. So step 3 is, here we have to take the Laplace inverse of xs. Laplace inverse of x of s. So it is x of t, 4 is common, constant. Laplace inverse of 1 by s minus 1 minus 3 is constant. Laplace inverse of 1 by s minus half minus half of Laplace inverse of 1 by s minus half square. Now for the first two terms we have the standard Laplace transform pair. Okay, for the first two terms we have standard Laplace transform pair, that is e raised to plus atu of t. Its Laplace transform is 1 by s minus a. This is for sigma greater than a. So we write here, therefore Laplace inverse of 1 by s minus 1 is e raised to t u of t, and Laplace inverse of 1 by s minus half, it is e raised to half t u of t. Now for the third term we use the standard Laplace transform pair. So standard Laplace transform pair, it is t raised to n n factorial divided by s minus a n plus 1. So we have the term Laplace inverse of 1 by s minus half square. So it's Laplace inverse of 1 factorial divided by s minus half raised to 1 plus 1. So it is t e raised to half t. Now the time domain sequence, in time domain we write all these sequence, that is x of t is equal to the first term 4 e raised to t u of t minus 3 e raised to half t u of t minus half t e raised to half t u of t. So this problem was asked for 5 mark in the exam. Here only a difference is that we have to calculate the second added term. We have to calculate the coefficient a2 in different ways because it is added term, and the second difference is that here we have to calculate the third term while taking the Laplace transform by using factorial form.